Hello, on this video, what we're going to do is we're going to play around with a simple population model of talking about gray squirrels in Great Britain. And the story here is that a gray squirrel population was introduced in a certain county of Great Britain 30 years ago. And biologists observed that the population doubles every 6 years. And now the population is 100,000. We will use a simple population model, which is saying that we assume that population growth is exponential. And this has some drawbacks, but it's a simple model. There are other models that are more involved. What I want to do before we even start is writing up like a little table of, without using a lot of heavy math, of some ideas of what we would get for the population. Now T is for time in years, and then what we're going to have is A, which is the population. And what I want to do is I want to assume that actually at time 0 we have 100,000. And someone might say, well, hold on, I thought time 0 was 30 years ago. But just to make this problem easier, I'm going to say time 0 we have 100,000. Okay, because that's the numbers given to us. It's right now it's 100,000. And okay, so let's just go with this. So that if it doubles every 6 years, the population doubles every 6 years, then at 6 years, times 6 years, I can take 100 and get 200. There's a whole idea that maybe I should drop the thousands so it's easier to write down. It's not a bad idea. Another 6 years, 6 plus 6 is 12. I have 400,000. Another 6 years, that's 18 years, I'll get 800,000. Now, if you wanted to find out what's happening, like how much there originally was, you could work backwards. You could go minus 6 years, and then minus 12 years. You can go all the way back 30 years. 6 goes into 5. 6 goes into 35 times. But if you wanted to go backwards, but let's do that later. But anyway, okay. So here we can sort of see what's going on simply by without doing really much calculations there. So that can be a good thing. But let's go ahead with answering these questions. Okay, what we have is that as stated, the doubling time is D equals 6. Now, the initial population at T equals 0 is, I'll put bullets, is A0 equals 100,000. The formula that's shown above is, okay, the thing is I just want to make some more space here. I feel like maybe I could just shrink this a little, move that over, and then just move all this stuff over. Okay, so, all right, the formula that we have for a simple population model is A, which is a population is the function of time, is A0 e to the kt. Now, K is given as ln 2 over D, which will be ln 2 over 6. Now, where does that formula come from? I derived it at a different time during a lecture, but that's a formula we can use. Okay, so now I have that A of t, putting this all together, A of t, put a bullet over there. Bullets are sort of dangerous because sometimes it might look like a math symbol, like multiplication or something. But A of t is A0, which is 100,000. E to the kt, well, k is ln 2 over 6 times t. So that's our answer to the first one. So we have a nice little formula. So now actually, If you wanted to find out the population 30 years ago, you could put in t equals negative 30, and you can punch it in there. You could also go back 6 years. So you start at 100,000. You go back 6 years. Say it doubles every 100,000 every 6 years. So if you go backwards, let me just do this. I'll just move this up for 1. If I went backwards 6 years, I get 50,000. So you can keep doing this. You go back and back and back until you get to minus 30 years. All right, estimate this squirrel population 10 years from now. Well, we have our nice little formula, and we'll just punch it in there. A of 10 equals 100,000 e to the ln 2 over 6 times 10. That simplifies a little bit to 100,000 e to the 5/3 ln 2. That looks like a good answer right there. That's the precise answer. But what I did do is I copied down the, from a calculator, because I did this before. I copied down from a calculator a rounded answer. What I don't want you to do is round and round, and then put in like some decimal things and keep rounding. You'll get an answer way off. I want you to write okay, so what do I mean by that? You could say, okay, I'm going to round off ln 2, put in a calculator, and then you get something rounded. Then you have 5/3 and round it off. If you keep rounding and plug it in, you'll get something that's off. It could be off by a lot than your actual answer. So what I want you to do is write down the exact value. That's what this is. ln 2 is an exact value, 5/3 exact value. And then if you want, you can put in the calculator. If you don't have a calculator, or if your calculator really doesn't work well for that, then don't do that. Okay, so does this make sense? 10 years is between, 10 years is somewhere in between here. Between 6 and 12, we know it's in between 6 and 12. And 300,000 and 317,000 is between 200,000 and 400,000. So just from that little rough chart I made, that seems to make sense. Now let's ask this next question, which really can get going. When will the squirrel population reach 500,000? We have A of t equals A0 e to the parentheses ln 2 over 6 times t. So when is A of t equal to 500,000? And I did this before. A0 for this problem is 100,000. Okay, so we already have that from above. Right, that was from above. So I'm going to put A as 500,000. And then that's 100,000 e to the ln 2 over 6t. By the way, this chart should also tell us a little bit, when do I think I'm going to have 500,000, because in between on this chart, let me do purple or something, or pink, 500,000 is somewhere between 400, 500,000 is between 400,000, 800,000. What value of t do I get over here? What's the time t? Well, okay, that's what we're doing. So it's going to be between 12 and 18 years if I do it right. So I have this guy here, and maybe I'll just copy and paste that. And what I want to do is I want to divide both sides by 100,000, because what I want to do is get that exponential all by itself. So I get 5 equals e ln 2 over 6 times t. Okay. And now I want to solve an exponential equation. We're trying to solve for t. Solving for t, what I do is I apply ln to both sides, because ln and exponential will cancel. Alrighty. Moving forward, ln and e cancel each other, and I get ln 5 equals ln 2 divided by 6 times t. Still trying to solve for t, so what I'll do now is I'll multiply both sides. Let me just show it. I'll pick a different color. I'll multiply by the reciprocal of ln 2 over 6. 6 over ln 2. I'll do that on both sides. And so I get that 6 ln 5 divided by ln 2 is equal to t. And then, just to make it fun, I can write down an approximation, which I already did before, so I didn't have to fumble around with my calculator. But, you know, during the video. But, okay, there we go. The exact value is what I wrote down here in terms of t is 6 ln 5 over ln 2. That's the exact value. That's the answer that you need to have written down. And then you can, if you feel like it, put down the calculator. It's 13.9 years. That's a little bit of work getting, you have to have a good calculator to do that easily. And so let me go back to this chart I have, this doubling chart. See, the chart came about from doubling. Every 6 years double. So you got 100,000, 200, 400, 800. When is it 500,000? What did it say? It's 13.9 years. That makes sense? 13.9 is between 12 and 18. You know, it's around 14 years. So around 14 years, we get the 500,000. That's what this is saying over here. Okay, so that finishes this video.